For this video, we're going to cover verifying a trigonometric identity. Now, the identity that we need to verify is as follows. 1 minus cosine of 2a all over 1 plus cosine of 2a is equal to secant squared a minus 1. Now, when we're verifying a trigonometric identity that has a double angle on the left side and a single angle on the right side, it is useful to use the double angle formula to help us convert the left side into the right side. So when we use the double angle formula, if a trig function has a double angle, then we can convert it to an expression that just has a single angle. So for this one, we have cosine of 2a. And if we consider the double angle formulas for cosine, they include cosine squared of a minus sine squared of a, 2 cosine squared of a minus 1, and 1 minus 2 sine squared of a. We can use any one of these to make our substitution. And then when we do so, we'll be further along our path to converting the left side into the right side. Now it is possible to convert the right side into the left side, but if we look at the two options, because the double angle formulas expand the left side, it may be easier to convert the left side into the right side. All right. So now let's see which one of the formulas we can use for cosine of 2a. If we consider the fact that we have cosine of 2a in the numerator and cosine of 2a in the denominator, and there's no other trig function for us to work with, it is advisable that we use a double angle formula that has just one of the trig functions. So we can use the one that just has cosine or the one that just has sine. That will make our simplification process easier because we're just going to have to deal with one type of trig function instead of two. And yeah, and it appears that we can use either this one or this one. The whichever one we use will change the process a little, but the result is going to be the same. So let's use 1 minus 2 sine squared of a. If we use 1 minus 2 sine squared of a, we get 1 minus, and then we put in parentheses 1 minus 2 sine squared of a. Now, if we don't use the parentheses, then it will be as though we're just subtracting the 1 instead of subtracting the entire 1 minus 2 sine squared of a. So we have to use parentheses when we're subtracting. And then in the denominator, we have 1 plus, and then in parentheses, 1 minus 2 sine squared of a. Now if we want to simplify the numerator, we can consider this negative here as a -1. So we can put like -1 here, and then we can just distribute it like this. So it becomes -1 times 1, that's -1, and then -1 times -2 sine squared of a, that's +2 sine squared of a. Yeah, because a negative times a positive is a negative, and a negative times a negative is a positive. All right, now for the denominator, since we're just adding, it's like we can put a 1 here and we're just distributing a positive 1. But we can also view it as just 1 times anything is itself. So we just end up with just the same thing. All right, so now we can focus on combining like terms. This 1 minus 1, they actually cancel because 1 minus 1 is 0. So these cancel. This 1 plus 1, it becomes 2. And then, of course, we just simply, yeah, everything else just stays the same. So we get 2 sine squared of A over 2 minus 2 sine squared of A. And then from here, like whenever we find ourselves in this situation where we have like something in the numerator, like it's just in terms of one trig function, like we have this in the numerator, and then we have like the same trig function in the denominator. Of course, we can always try factoring to see if that helps us. So in the denominator, it looks like we can factor out a greatest common factor of 2. So we put 2 on the outside of the parentheses, and then on the inside of the parentheses, we put 1 minus sine squared of A. And then from here, it looks like, okay, we have 2 times everything else in the numerator and 2 times everything else in the denominator. So in this situation, we can cancel out the 2. But let's keep in mind, we can't cancel out the 2's here because in order for us to cancel out something, it has to be multiplied to everything else, or we have to be able to write it as though it's being multiplied to everything else. So when we factor out the 2, we're writing it in a form where we can multiply it to everything else, and then that way we're able to just cancel out the 2 on the outside. Yeah, so we won't be able to cancel these out here, but once we factor out this 2, then we can cancel this 2 out and cancel that out. All right, now we have sine squared of A over 1 minus sine squared of A. Now here, let's see, it doesn't look like there's really anything else we can do to simplify just using algebra. So what we're going to do is we're going to have to take advantage of an identity. Now, we may ask, which identity are we taking advantage of? Well, the identity is like this. Basically, if you have sine squared of A plus cosine squared of A, that's actually going to equal 1. So sine squared of A plus cosine squared of A equals 1. Now, now the thing is, we're not always able to use the identities directly as they are. We may have to use a little bit of algebra to try to manipulate the equation so that we get an expression that matches what we have here. So it appears that like if we want to get 1 minus sine squared of A, we're just going to subtract sine squared of A from both sides. So that ends up getting us like we're just going to have cosine squared of A on this side, and then on the right side we have 1 and then minus sine squared of A. So we actually end up just having cosine squared of A only, and that's going to equal 1 minus sine squared of A. So 1 minus sine squared of A is actually equal to cosine squared of A. So now we can just replace the 1 minus sine squared of A to well, we can replace 1 minus sine squared of A with cosine squared of A. All right. So now we have sine squared of A over cosine squared of A. Okay. So now we may ask ourselves, well, what does this equal? So what is sine over cosine? Now the thing is, like, if we consider sine over cosine, that's actually going to equal tangent. So that's another identity that we can use. Sine over cosine is equal to tangent. So that means that sine squared over cosine squared has to equal tangent squared. All right, and then from here, to convert tangent squared of A to our final result, we're going to have to take advantage of this particular identity. 1 plus tangent squared of A is equal to secant squared of A. And just using a little bit of algebra, we can just subtract this 1 from both sides. So we get secant squared of A minus 1 on the right side. And then on the left side, like we just have tangent squared of A. So tangent squared of A is actually equal to secant squared of A minus 1. So we're able to rewrite it as secant squared of A minus 1. And yeah, and that is the completion of our verification of the identity.